Welcome back. Our whole goal is to solve problems and to use data to help us do it. Once we do the analysis, well, then it's time to interpret the analyses so that we can share those answers and use the answers to make decisions, take action, and finally solve that problem. So, there's really only two ways that you're going to interpret those analyses and those answers to your questions. You're either going to provide descriptions or you're going to provide inferences. So let's start with descriptions. This is what it sounds like. You're going to describe. Anytime your problem requires answers to questions like what happened or what is happening, your task of interpreting is pretty straightforward. If your goal is to describe, you just do that. You provide the actual numerical values from your analysis or from your qualitative findings. But what you don't do is provide a subjective interpretation of that information. Because again, our whole point is to describe what you find. If you want to infer something from your data, anytime that you're trying to imply causation, you want to test something, you want to predict something, well, that's a whole nother ballgame. At that point, you've officially moved out of the easier interpretation land of just describing what you found, and then you'll actually need to add a little extra something something to your steps of your analysis and how you talk about your findings. You're going to have to add on this concept of significance. So the word significance means the quality of being worthy of attention. And there is more than just one kind of significance, especially when we're talking about analytics. So let's go through them. Statistical significance. This seeks to assess how likely the results you got were simply due to chance or maybe even error. It's an actual calculation that takes into account your data and the amount of data you have, and it produces a numerical value from 0 to 1 called a p-value. That value can be talked about as a percentage and as the percent or probability of observing a result at least as extreme as the one you saw in your data when there was actually no effect, and it was just chance that made it look that way. You can also think of it like a probability of getting a false positive. When you hear someone call something statistically significant, what they're saying is that the p-value they got is lower than a predefined threshold that they're comfortable with. This threshold is called a significance or alpha level. The alpha level is actually something you get to choose based on how bad a false positive would be in your particular situation. But most people like to default to saying an alpha level of 0.05 or maybe a 0.01 or a 0.001. An extremely important thing that you want to keep in mind is that statistical significance does not tell you anything about whether or not your results are big or important or meaningful, or really anything at all other than just the likelihood of seeing these results due to chance. And statistical significance can often be reached simply by having a large enough sample size. So once you're working with really, really large data sets, it could become irrelevant or more likely just require you to need to take additional steps like random sampling to really be able to use it. So you want to make sure that it is not the only kind of a significance you pay attention to. Which brings me to practical significance. Now, practical significance is concerned with whether or not your findings have any real-world importance. Even if something is statistically significant, it might not be practically of use. So, for example, a study might find a statistically significant difference in website conversion rates between two different background colors of the website. But if the difference is only 0.01%, it probably isn't worth the effort of changing the color. In order to identify practical significance, there are some calculations to do things like measure effect sizes and magnitudes, and even in some industries, There might be some guidelines or specific variables and key topics where practical significance has preset, generally accepted thresholds. But for most of the time, practical significance is going to be a subjective process, and you, maybe alongside stakeholders or the people that you work with, you are going to have to discuss and talk about what practically significant means for you and determine that together. Now, finally, social significance. So, this one isn't really an official term, but I have been trying to get it to catch on. I like to use it to remind people how important it is to not just assess how likely our analyses are to be accurate, which would be statistical significance, and not just how useful they can be for business purposes, which would be practical significance, but also whether the decisions that they inform may impact people. If you remember, our definition of significance is the quality of being worthy of attention. And we've just seen too many instances of data-driven decisions that impact people's lives and algorithmic injustices to be able to continue to believe that there isn't something worthy of consideration when it comes to how our analyses might be worthy of attention in a social sense. So, while there's no official mathematical approach for this, I encourage you to pause and consider whether or not there may be positive, negative, or neutral potential outcomes that could impact others as a result of the analyses and in the context of the problems that you're trying to solve. I can't help but think, like, how cool would it be if there actually was like a little mathematical calculation? I mean, like, I kind of want there to be an H value, like the P value, but instead of the probability of being wrong, it could be like the probability of doing harm. And also, because my name is Heather, so we could call it the H value. Okay, anyway, sorry, I digress. Back to data-driven problem solving. All right, once you have your data and you've analyzed it and you've interpreted how statistically, practically, and socially significant it is, well, it's time to share your results with others. Our next video is actually going to dive much deeper into this topic. So for now, I'm going to leave you with some helpful tips when sharing your data findings. First up, know your audience. You will need to tailor your presentations, emails, or reports to the level of your audience's data literacy. That means sometimes explaining what certain statistics means and sometimes knowing when not to be condescending by explaining what they mean. A little tip, if you're ever unsure, you should err on the side of explaining them, or something I like to do is to put the definitions as a little footnote somewhere. That way, nobody ever has to be explained to, but also nobody ever has to ask the question either. But regardless of your audience's data literacy levels, always use the most clear, concise, and simple language possible, and avoid jargon or specialized language whenever you can. Focus on relevant analyses only. Don't overwhelm your audience with every single analysis that you did. The truth is, you're going to run so many more analyses than you will ever share with others. They don't need to see all of that. I know you worked hard, but just share the points that directly support your conclusions so that you don't lose their attention. Less really is more. If you feel like you have to put in that stuff, use an appendix, let them know it's there, but don't force them to look. And don't expect them to look either. And when I say focus on relevant analyses, I should also mention focus on analyses. When sharing your data findings, it's important that you keep it evidence-based and do not input your own opinions and personal beliefs. This can be hard because you've spent a lot of time with the data and you probably have a lot of feelings and opinions and personal thoughts on the matters that you've been analyzing. But it's important to remember here all those cognitive biases that we talked about in an earlier video, and not allow your own biases to creep in and accidentally influence others. If you do need to provide a personal opinion, because maybe you were literally hired to do that, well, just make sure it's placed in its own separate section with a clear header or disclaimer that indicates that you're now switching from the data-driven portion to the part where you're sharing your own personal opinion. And I hope this tip goes without saying, but you should triple, actually quadruple check your data and analyses for accuracy before sharing. Even just one little tiny error can leave your audience wondering just how many other things were wrong in what you shared. So even if you're bored of looking at your own stuff, just check it, check it, check it, check it. You don't want that one little error making everything else seem like it could be false. And finally, I always recommend use some effective visualizations when they're appropriate, and don't just share information, tell a story. These last 2 points, by the way, are exactly what we're going to get into in our next video, so I hope to see you again.